Hello and welcome to ISG Blandford. This is DNS Part 2. This is DNS on the Internet. In the previous video, in the first part of the series of 3 videos, we looked at DNS on the local intranet. We covered a bit of an introduction and we looked at resolution using zones and looked at the resource records which are stored in those zones. We also looked at a fault tolerant version of DNS as well. Today we're going to have a look at using the DNS cache and using root hints and the domain namespace. We're also going to look a quick look at the DNS query responses. So as we know, the DNS uses a number of methods to resolve queries, 4 DNS queries. The first being cache, second being the zone, which we've looked at previously. Third is forwarding, and finally the fourth one is using root hints. So in this edition we're going to be looking at the cache and how that works, and using root hints and how that works to resolve DNS queries. So the cache works in a number of different ways. For the application, there is a cache which stores the FQDN to IP mappings. There's also a cache on the local operating system, and there's also a cache on your local DNS server and on the other DNS servers which are placed on the internet. The local cache can actually be displayed on your machine if you type in ipconfig/ds display DNS, and that cache can actually be deleted by ipconfig/flush DNS. The host text file, which is stored on your etc folder within your system32 machine on your local machine, the host file actually populates that cache, so by flushing the DNS from that cache you'll still see the contents of that host file in your local cache. Finally, on Microsoft, if you go into the DNS server, go into View on the DNS console and click Advanced, you'll be able to see the DNS server cache, and shows all the cached records there. Actually happens in real life. Just imagine that google.com had never been gone to ever. It was a brand new server, and .com was also a brand new top level domain. So what would happen? First of all, the person would type in www.google.com. The DNS query would be put out. What was the IP address for that FQDN? The DNS server here on the local domain will look into its cache initially, and you'll see at the moment it's empty. It'll also check its zone. At this point here we see that google.com is not in that zone there. That zone is not authoritative for that FQDN. So what will happen, the next thing it will check is its forwarding. Nothing is configured for forwarding, and finally it will use its root hints to go over the internet. Now we're going to look at root hints later, but for the time being, if you just imagine that it goes over the internet and it gets back the DNS server for google.com, and then asks that server what the IP address is for google.com. That'll then return it with the response, a DNS authoritative response, which we'll look at later. But the thing we need to concentrate on now is the fact that that cache then gets populated with that A record. So the google.com A record is put down as a certain IP address. The DNS response then is then a positive response from that DNS server, and the IP address is given for the client, and the client connects directly to google.com. Now the next user that then connects to that DNS server with a query, what is the IP address for www.google.com, it's already stored in the cache, so that reduces the amount of time and effort that the server needs to do by going over the internet, because it's just a very straightforward positive DNS query response, gives it the IP address, and then that can connect to www.google.com. Okay, so that's how DNS works, resolving using a cache, and how the cache populates. And how DNS really works over the internet is a lot of the time when you're going to websites, you're actually loading your records from a cache. Root hints is the very last resort and is used the least amount, but is arguably one of the most important parts of the DNS resolution and the whole DNS hierarchy and how the domain names work. So let's have a look at the problem. Millions and trillions, arguably, websites out there. I've got a number of them up here with different top-level domains, different second-level domains. So we've got the contoso.de with the top-level domain DE, and the second-level domain contoso. We've got all these companies here and organisations, so how do they connect to each other and find out what the IP addresses of their web servers and other services which these companies offer? The solution is to create a hierarchical namespace. Now, we talked previously about hierarchical namespace, but now we're going to understand what that actually is. When we write in the term www.google.com, we're actually quite lazy in computer science here. We don't include the dot on the end, which actually is the full name. So it's www.google.com dot. Now this dot is the thing which kicks off the hierarchical namespace. The dot server is the server which stores all of the IP addresses for the top level domain names. Those top level domain names store all the IP addresses for the second level domain names. So to find the .com DNS server, you go to the root namespace. To find the Google DNS server, you go to the com namespace. And then to find the web servers for Google, then you go to Google, and that gives you the names of the web servers. Let's have a look at how that works in practice. So here we've got someone connected to their ISP. At this point here it happens to be ntl.com, so this could be you at home working with your NTL connection. This is a recursive query. You send out a DNS query. What is the website for web.litware.biz? What is the IP address for that service or server? Is it in the cache? No. Is that particular ntl.com DNS server authoritative? No. Forwarding is not configured, which we're going to look at later. So it does its last port of call, which is its root hints. In the DNS server, a number of IP addresses are stored within the DNS server for the root servers which are based throughout the world. These are known as the root hints, so it's literally a list of IP addresses with reference to a list of root servers which are stored over the world. This can then send a DNS query to one of these root servers, these dot servers. So the DNS query here is what is the A record for web.litware.biz? The dot or root web server comes back and says, checks its cache, it's not in there, checks its zone, it's not in there, checks its forwarding, it's not in there, and it comes back and it gives it a referral. It will give a referral. It says, I don't have the IP address for that A record, but I can refer you to the next level down, which in this case is the .biz DNS server. Then the query goes out to the .biz server. What is the A record for web.litware.biz? Again, these queries are all sent out using UDP as transactionless or connectionless methods of protocol. Sends out query A record for web.litware.biz. Again, it's not authoritative for that zone, but it does come back with a referral response. The referral response is I've got the IP address for the litware.biz DNS server. Then the DNS query goes out then to the actual litware.biz DNS server. What is the A record for web.litware.biz? So far we've had referral responses, but the final response, which we're going to get here, is the authoritative response. As you'll have noticed there, the ntl.com DNS server would have cached that record for other users looking to go to that web server. Provides the authoritative response with the A record, so provides the IP address to that machine, to that DNS server. That DNS server then completes the full process and passes the IP address back to the user connected to ntl.com, and then they connect using the correct IP address to that web server. So that's the full recursive query. Occasionally with DNS servers, the recursor, which is the normal method of traversing through the internet, is switched off. It could be because the particular server is not a domain controller, or there's some security problems with it, so they'll turn off the recursive method of recursive query. So the iterative query is very similar, except the workload is put and done completely by the client server. So again, it starts out in a similar way. The query is, what is the A record for web.litware.biz? Is it in the cache? No. Is it authoritative? No. Forwarding is not activated on this particular server, so it goes and doesn't and cannot provide any other response, only than a referral response using its root hints. So those root hints go back and gives it an IP address for the root hints, the dot server. The root server, then the query is sent to that. Referral then comes back from the DNS root server for the .biz top level domain. As you'll notice here though, the actual host that does the work here is the client, and this happens in exactly the same way for the rest of the queries throughout the process, but it's all done by the client side as opposed to the DNS server. So the query responses which we've looked at today is a positive answer. So this occurs when we were looking at our cache. If it's stored in its cache, then it'll be a positive answer because it will have the IP or a record or a PTR record or whatever record it's looking for. We've got an authoritative answer. So we've looked at using the cache today, we've looked at using root hints and the domain namespace, and we've looked very quickly at DNS query responses. So next time what you're going to find is we're going to look at managing DNS requests, because when you're using DNS you need to manage the amount of UDP messages that get sent over the internet. The more UDP messages that get sent over the internet and received back from the DNS server, then the more chance that security could be compromised. So DNS has got a number of clever tricks to try and get around and manage how these requests are dealt with. So these include delegating authority to other DNS servers, forwarding from internal to external DNS servers, conditional forwarding to actual domain names, and stub zones, which is very similar to conditional forwarding. So we're going to look at those in the third of this 3-part